Welcome to Unit 6. This is 6.1 Pythagorean Theorem. We're going to start with the actual theorem. If we had legs of a triangle or right triangle that are A and B, then our hypotenuse is C. So both A and B are legs. Across from the 90, which is the hypotenuse is C, it is always the longest in length. And it has to be a right triangle in order for this theorem to work. And that is A squared plus B squared equals C squared. So to use the Pythagorean theorem, if we have a triangle here, A and B are x and 3, it doesn't matter which is which, and C is 5 in this question. So we have x squared plus 3 squared equals 5 squared, 3 squared is 9, 5 squared is 25, subtract 9 from both sides, we get 16, take the square root and we get 4. Okay, so that is how we find a side length. You could also find the hypotenuse using this method, a squared plus b squared equals c squared, where c is x in this question, 4 and 6 are a and b, it doesn't matter which is which. 4 squared plus 6 squared equals x squared, we get 16 and 36, add them together and we get 52. Now to get x by itself, we take the square root, and that's the square root of 52, which is the same as saying 4 times 13. Square root of 4 is 2, 13 stays in the radical. And that was simplifying radicals there. Okay, we can use Pythagorean theorem to find area. So here we have to find the height of the triangle. If we're going to do Pythagorean theorem, we first have to break up that 30 into two parts, which is 15 and 15, and that's because it was an isosceles triangle. Okay, now we can use 15 as our A and 18 as our C. H is our either B or A. 15 squared is 225, 18 squared is 324. Subtract 225, we get 99. Take the square root, and it should simplify down to 3 squared 11. Right, 9 times 11. Square root of 9 is 3. So now that we know our height, the area of a triangle is 1/2 base times height. 1/2 times the base is 30, and the height is 3 squared 11. Right, half of 30 is 15. 15 times 3 is 45, so it's actually 45 squared 11 square feet if we're going to keep it in radical form. Okay, so some aren't perfect squares, and the reason is because if you have three positive integers, a, b, and c, in order to satisfy a squared, b squared, and c squared, they'd have to be what's called a Pythagorean triple. These are common triples that you will see, especially on the ACT, and that's 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. I will say the most common is 3, 4, 5, and 5, 12, 13. I would memorize those so you can quickly use them on the ACT. But also the multiples of these also work. So if we double everything, and we get 6, 8, 10, 10, 24, 26, so on and so forth. If we triple them, anything 3 times, 4 times, 5 times is a 3, 4, 5 triangle. Okay, so these are just common ones, again, you can see and use on ACT very quickly. Next, the converse of Pythagorean theorem, so the backwards. The idea is if c squared equals a squared plus b squared, then it's a right triangle. But we can also use this to tell us if it's an acute or obtuse. If c squared is less, it's an acute. If c squared is greater than, it's obtuse. Okay, so we always determine it based off of c squared. Okay, equal is right, less is acute, greater is obtuse. So here, we have 9, 15, and 3 squared of 34. 9 squared plus 15 squared. So we're going to first do 3 squared of 34 squared. And then we're going to see what that is compared to 9 squared plus 15 squared. We get 306 on both sides of the equation. That is equal, therefore it forms a right triangle. Over on B, when we do 26 squared, it's 676. And 22 squared plus 13 squared is 653. That is greater, so it is obtuse. We can also see word problems with these. So how high up on the wall will a 20-foot ladder reach if the foot of the ladder is placed 5 feet away? Well, 5 is a leg, and the hypotenuse is the ladder, so that's a 20-foot ladder. H is the wall. How high up on the wall? Okay, so we do 5 squared plus h squared equals 20 squared. We get 25 and 400. Subtract 25, that's 375. The square root of 375, that's 25 times 15. And that square root of 25 is 5, so it's 5 squared of 15 feet. Right, that is Pythagorean theorem. Good luck on the practice.